tutorial on balancing chemical equations. Today, we'll be balancing the equation for the combustion of butane. Let's start with our unbalanced equation. C4H10 plus O2 yields CO2 plus H2O. The first step in balancing a chemical equation is to count the atoms of each element on both sides of the equation. Let's start with the left side. We have 4 carbon atoms, 10 hydrogen atoms, and 2 oxygen atoms. On the right side, we have 1 carbon atom, 2 hydrogen atoms, and 3 oxygen atoms. Now, let's balance the equation step by step. We'll start with carbon. We need 4 carbon atoms on the right side to match the left side. So, we'll add a coefficient of 4 to CO2. Next, let's balance hydrogen. We need 10 hydrogen atoms on the right side. We can achieve this by adding a coefficient of 5 to H2O. Finally, we need to balance oxygen. We now have 13 oxygen atoms on the right side, but only 2 on the left. To balance this, we need to add a coefficient of 13 to 2 or 6.5 to O2 on the left side. However, we typically avoid fractional coefficients in chemical equations. To eliminate the fraction, we can multiply the entire equation by 2. This gives us our final balanced equation. Let's verify that our equation is now balanced. On both sides, we now have 8 carbon atoms, 20 hydrogen atoms, and 26 oxygen atoms. The equation is perfectly balanced. In summary, we've balanced the chemical equation for the combustion of butane by following these steps. 1. Count the atoms of each element on both sides. 2. Balance carbon by adjusting the coefficient of CO2. 3. Balance hydrogen by adjusting the coefficient of H2O. 4. Balance oxygen by adjusting the coefficient of O2. 5. Eliminate fractions by multiplying the entire equation by 2. Our final balanced equation is 2C4H10 plus 13 O2 yields 8CO2 plus 10H2O.